Okay, last question on this paper. And what we've got is the diagram below shows a wooden end piece for a curtain pole. It's in the shape of a cone and the measurements are on it. It says the curtain pole sits in a cylindrical hole that has been drilled into the end piece. The hole is of radius 3 centimetres and depth 4. So that's this little bit here drawn with the dotted line. So that's cut out of the shape. So what I want to do is show that the volume of the wood that remains is 64 pi. So I need to work out the volume of the cone, first of all, the whole cone. Okay, and if we flip to the front of our booklet, we have got a cone here, and it tells us the volume. So it's a third pi r squared times h. So a third pi r squared h. We know all this information. We don't need to worry about pi because we want pi in our answer. So it's a third times pi times the radius. Well, this is the whole width of the cone, so that's the diameter. So the radius is half it, it's 5 squared, times h. This is the height of the cone, so it's 12. What I'm going to do first of all is I'm going to get rid of this third. I'm going to work out a third of 12 because that's the easiest thing to get rid of. You could do a third of it at the end, so you could divide it by 3 at the end, but I think it's easier this way. So if I get rid of the third and the 12, that leaves me with just 4, because a third of 12 is 4. So I've got pi times 25 times 4, which is just 100 pi. Now we have to work out the volume of this cylinder in here. You're not told the volume of a cylinder formula, you need to know it. It's the area of a circle, so pi r squared times by the height. So it's pi times, we're told here that the radius is 3 and the height or the depth in this case is 4. So I'm doing pi times 9 times 4, which is 36 pi. So to work out the volume of what's left with this piece taken out, I would do 100 pi, take away 36 pi, which is 64 pi, exactly what we wanted. Part B. It says the surface area of the end piece is to be painted, except for the area inside the hole. Calculate the surface area that is to be painted. Give your answers in terms of pi. I'm going to work out first of all the surface area of the hole that's cut out at the bottom. Okay, so surface area from base of cylinder. Okay, so it's just the area of a circle, so it's pi times radius squared, and it's the cylinder one, so it's 3 centimetres for the radius, so it's pi times 3 squared, so that's 9 pi. So I'm going to take that bit off the end once I've worked out my surface area for the cone. Again, I'm told this at the front of my booklet. Curved surface area of a cone. Make note, it just says the curved. So actually all I'm working out is this top piece. So I'll have to work out the base of the cone as well separately. So let's do the curved part first. So surface area of curved, so we're doing the cone here, it's pi r l. Okay, we know the radius, we know pi. We don't know the length though. If we look at the diagram at the front, the length is this slanted length here. So I need to work out this length here. So this is L. Now, if I drew this out, if I draw a dotted line down here, okay, and I join it across here, what I've actually got is a lovely right angle triangle. Okay, so you're going to use Pythagoras. I know the height here is 12. I know that this width is the radius, so it's 5. So I'm working out the longest side of a right angle triangle. So I'm going to use Pythagoras to work out the length. So to work out L, Pythag. So I've got 12 squared plus 5 squared equals my L squared. Well, 12 squared is 144, plus 25 equals L squared. This is 169, and then we do the square root, which is 13 centimetres. So we now know that L is 13 centimetres. So we're going to do pi times 5 times 13. 13 times 5 is 65, so it's 65 pi. So that's the curved surface area. We now need to do, so we're doing the base circle of the cone. And again, we're just using pi times radius squared. So it's pi times 5 squared, which is 25 pi. So I'm going to use these three things that I know now. The total surface area of the whole cone is 65 pi plus 25 pi, which is 90 pi. I now need to take away the part from the cylinder. So 90 pi, take away 9 pi. So my answer is 81 pi.